All right, let's take a peek at parallel and perpendicular lines. So these are two specific styles of lines, and we want to see if we can see anything about them. So we're going to use Desmos, and we're going to type these in, and let's see what happens. All right, first line is y equals 2x minus 3. Our next line is y equals 2x plus 1. And our third line is y equals 2x minus 2. So what do we see? Well, they all have a different y-intercept. Okay, so one's at -2, one, -3. Yeah, makes sense. 1, -2, -3. Are they ever going to cross each other? Nope. Nope, they will never, ever, 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 ever cross each other. That's pretty interesting. Notice how they all have the same slope, and because they all have the same slope, they are therefore parallel to each other. So let's write that out. So they all had the same slope. They were parallel and will never cross each other. Okay, how about we try the ones for B? Let's see what they look like. Okay, so back in Desmos, y equals -1/2 x plus 4. Y equals -1/2 x plus 2. Oops, 2 x's. And y equals -1/2 x minus 1. So again, we've got different y-intercepts, -1, 2, 4. And again, now we've got the same slope. They are again never, ever, 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 ever going to cross. So these lines are parallel. So that's pretty neat. Okay, let's put those first lines back in here. So y equals 2x minus 3. We had y equals 2x plus 1. And we had y equals 2x minus 2. So what do we notice here? Interesting. They do all cross each other, so the one group crosses the other one. Does that look like right angles to you? I think those look like right angles. They look perfectly perpendicular. So let's jot that down. So in B, they all had the same slope, so that was the -1/2. Therefore, parallel. And then notice that slope of 2 and slope of -1/2 look perpendicular to each other. And what does perpendicular mean? That means 90 degrees. So they are at exact right angles to each other, because right angle is 90 degrees. Okay, we've got a third set of lines in here that I did want to look at, so let's graph those and see what we see. All right, so I have them in standard form, but Desmos can still handle it. X plus y plus 4 equals 0. We have 2x plus 2y plus 8 equals 0. And we have 3x plus 3y plus 12 equals 0. Oh, where's all my lines? I only see one line here. Let's see, let's take off the black line. Oh, there's the blue line. Let's take off the blue line. Oh, there's the green line. Oh. So when you have lines that are multiples of each other, so notice if I took all of these times by 2, I get this one. And if I took all of these and times by 3, I get this one. These lines we call coincident lines. So let's just write that down. Okay, so lines that are multiples of each other are the same line, and they're called coincident lines. Okay, so I took my first line, x plus y plus 4 equals 0, and I took that whole thing and I times it by 2 times it to get the second line. And to get my third line, I did 3 times it. So they were multiples of the same line. Therefore, they're called coincident lines. Okay, let's try these ones. So I'm going to graph y equals 2x plus 3. So we're in slope y-intercept form. So I have a dot at y equals 3. And then that tells me my slope. So I have a So that means I have a rise of 2 and a run of 1. So go up 1, 2 over 1, new dot. Up 2 over 1, new dot. So that's enough to give me a line. Okay, let's graph the next one. So y equals negative 1/2 plus 1. So my plus 1 is my y-intercept here. And then my slope is negative 1 over 2. So that means I'm going to go down 1 over 2. Down 1 over 2, down 1 over 2. Well, that's lots for a line. Okay, so I've got my 2 lines here now, and I just popped a protractor on, and if you notice, so we line up the bottom edge with one line, put the center of it right on top of the center, and let's see, these guys are 90 degrees apart. And remember, 90 degrees is a right angle triangle, or is a right angle, 90 degrees. So these guys are perpendicular. Cool, eh? Okay, let's graph the next set of lines. So here I have a y-intercept of positive 3. There's my rise, there's my run. So I'm going to go down 2, right 3. So let's go down 2, right 3. There's a dot. Down 2, right 3. There's a dot. And then we make our line. Okay, and let's do our next line. So we've got a y-intercept of negative 4. So negative 4. Slope here is telling me I need to go up 3 to the right 2. So I'm going to go up 1, 2, 3 over 2. Dot 1, 2, 3 over 2. Dot 1, 2, 3 over 2. Dot. And while you only need two dots to draw a line, I find a couple makes it easier. So then I can kind of wiggle, wiggle, wiggle and make sure I get it just right. So there's my line. And if I were to bring over my protractor, let's see what it does. Line it up. See, give it a little tilt to line it up perfectly. Centered. You gotta center it. Line it back up a bit. And did you get it? Look at that. 90 degrees. Perpendicular. Okay, let's try this one more time. So here I have a y-intercept of plus 1. So plus 1. And negative x means I have a slope of negative 1 over 1. So I'm going to go down 1 over 1. Down 1 over 1. Down 1 over 1. Good. So that'll give me a line. Okay, and now I've got a y-intercept of negative 3. There's my dot. And x means I have a slope of 1 over 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. So let's graph that line. All right, we've got our 2 lines now. Let's check this out. Rotate to line up. Make sure my center is right on the center. I'm not quite there. Line it up. And there you have it, folks. 90 degrees. So all 3 pairs of these lines ended up being perpendicular. They were 90 degrees to each other. That means perpendicular. So how can we tell lines are parallel just from their equations? So that meant that they had the same slope, right? They had the same slope. Well, perpendicular, let's look at their slopes here. So here I've got a 2 and a 1 over 2. That's negative. Here I have a 2 over 3. That's negative versus a positive 3 over 2. Huh. Here I have a negative 1 over 1 versus a positive 1 over 1. So what we can see with these slopes is that they are what we call negative reciprocals of each other. So to be perpendicular, the slopes are called negative reciprocals of each other. So what that means is slope 1 is, say, A over B. The perpendicular slope has to be equal to negative b over a. Okay, let's put that into action here. So we've got the equation of a line is y equals 3x minus 4. We want the slope of a parallel line and the slope of a perpendicular line. So to be perfectly honest, we don't care about this at all. We don't care about anything else. We only care about this number. So the slope of our line is 3. So the slope of a parallel line, so you draw two little parallel lines there, is the same value. And the slope of a perpendicular line would be negative 1 over 3. Because this slope was a positive 3 over 1, flip your fraction, make it negative. Let's look at this one. So here I have y equals 3 over 5, x plus 2. So again, the only thing we care about is that number that's attached to the x. And this time it is a fraction already. So the slope of a parallel line is going to be the exact same numbers. And the slope of a perpendicular line is going to be negative, flip your fraction, 5 over 3. Let's do a few more examples. So just like one of the questions in your homework, here I have a line in standard form. So in order to figure out equations of lines that are perpendicular to it or that parallel to it, we need our slope. Need slope, which means I'm going to have to rearrange into y equals mx plus b. So how do we do that? We leave the 3y on this side and we're going to move everything to the other side. So we're going to minus 5x from both sides. So that leaves me with 3y plus 10 equals negative 5x. And then we're going to move our 10 to the other side. So let's minus 10 from both sides. So you get 3y equals negative 5x minus 10. And then last step, we got to move that 3 out of the way. So we're going to divide each term by 3. So we now have y equals negative 5 over 3x minus 10 over 3. And it's fine to be a fraction. That's quite all right. That is a perfectly legitimate number. Now, if I want to write the equations of two lines that are parallel to this line, well, I have to make sure each one starts with y equals negative 5 over 3x. So y equals negative 5 over 3x. So there's line 1, there's line 2. And the only thing that I do change is my y-intercept. And it can be any number you want. It could be plus 100. It could be minus 3. Whatever. Doesn't matter. That's the only number that you really need to change. Make sure you keep the slope the same. Okay? If I'm going to write the equations of two lines that are perpendicular to this line, well, that would mean that instead of the same slope, I need to change it. So instead of negative, it is now going to be positive. And I flip my fraction, 3 over 5. So now I've got one line that's going to have a 3 over 5x plus or minus any number you want. So let's say, I don't know, minus 6. And y2. So another line that's perpendicular will have the slope 3 over 5. And I don't know, let's make it plus 8. Sure. Okay, let's do another one that's going to be just like your homework. Here I have a triangle, and it's got vertices. Remember, that means it's corners, right? The pointy ends. They're not really corners, the pointy ends. So we've got a point at negative 1, 3. And don't forget that our points are always done with round brackets. There's my x, there's my y, right? So negative 1, 3. So there's point A. 3, 5 is going to be point B. And 5, 1 is point C. So we turn these into a triangle. So there's my lovely triangle. And what we want to figure out is whether or not this is a right angle triangle. So is one of these angles 90 degrees? So inspecting it, I would say that our best bet for a 90 degree would be up in the corner B, vertex B. So that means we have to figure out if line AB is perpendicular to line BC. That's the question we're looking for here. So we got to figure out our slopes. Well, we know our points, we can figure out a slope. So I want to find the slope of AB. So I'm going to use my y2 minus y1 over x2 minus x1 equation. So A and B, let's see. B is those values, minus, minus. A is these values, 3, negative 1. 5 minus 3 is 2. 3 minus negative 1 gives me 4. So the slope of that line is 1/2. Okay, so this side here, we know its slope. Let's do the slope of BC. Again, we're going to do y2 minus y1 over x2 minus x1. So point B, oh, I lost my vertices. Vertices, here we go. So line or dot B is at those values, and C is at these values. 5 minus 1 is 4. 3 minus 5 gives me negative 2. Simplify those, and that gives me a value of negative 2 over 1. And look at that, flip the fraction, 1's negative, therefore AB is perpendicular to BC, therefore this is a right angle triangle. And you're done. Okay, this one's pretty tricky. We've got 2 vertices of a right angle triangle, so we're told it's a right angle triangle, and then we're told that we've got a vertex at 1, 4. So I'm going to put my dot there. Let's call you A. So that's A. B, we're going to call this one B, is at 9, 3. So there's dot B. And then we're told, and here's the tricky part, that the third vertex is somewhere on the x-axis. So we need to figure out what its coordinates are going to be. Tricky. So we do know that if it's on the x-axis, that I don't know my x value, but I do know my y value is going to be 0. And if I'm going to have a right angle triangle, well, we can figure this out. Sure, let's totally do it. Okay, so line AB, let's figure out our slope of line AB. So we know that that's going to be y2 minus y1 over x2 minus x1. We know B is at 3, 9. My y value for A is 4. My x is 1. So that gives me a slope of negative 1 over 8. So that means the slope of my perpendicular line is going to have to be positive 8 over 1. So from point A, I could find a slope that is a positive 8 over 1. So let's see, if I'm going to go left 1, then that means down 8. 1, 2, 3, 4, 5, 6, 7, 8. There's the slope of the line. There's my line that's perpendicular. And remember that the vertex is on the x-axis, which means that my triangle is going to go from here to there. So my third vertex at point C would have to be 0. That looks like 0.50. Now that's not my only option. I could have a line that's perpendicular at B and have a different triangle. So let's find that one. Okay, so same slope. So it's still going to be a rise of 8. 1, 2, 3, 4, 5, 6, 7, 8. And over 1. Oops. 1, 2, 3, 4, 5, 6, 7, 8. And 1. So let's draw that line up and through B. So that would be my perpendicular line there. So to finish off my triangle, where is it crossing? Here and there. So I would have that line as well. So that point would be here. There's my 90 degrees there. And there we have it. 2 possible triangles given the information we were given. Well done.